My name is Cornelia Davis. I'm a developer advocate here at Temporal, and I'm going to be your MC today and participate with Steve and Dom as well on going through the content today. I have a long history and I spent a lot of time doing microservice architectures, and now you'll see as we go through the content that bringing that distributed systems knowledge over into this world of AI is just the most exciting thing ever. So super excited to be here with all of you. Dom, if you want to introduce yourself.
Sure. Hi, everyone. Great to meet you. I'm Dom. I work on developer experience at OpenAI. That sort of ranges a broad range, but includes, among other things, building the Agents SDK in TypeScript and contributing to the Python one. So very excited to talk to you all about it. Steve?
Hey, yeah, Steve Angelakis is my name. I'm based in Seattle and I've been at Temporal 2.5 years. As a solutions architect, my job is to help some of the biggest companies out there use Temporal, get the most out of Temporal. For example, OpenAI is a Temporal user, as you may have guessed from Dom's representation. Stripe, Netflix, some other large sort of technically advanced companies like that. And I'll be doing a demo towards the end of this webinar.
Awesome. So all three of us are going to be chiming in throughout. And again, I would invite you all to do that. Uh, just a little bit of housekeeping before we jump into the main program. We're shooting for around 45 minutes. We will definitely do Q&A at the end of the presentation, but we're also going to be monitoring the Q&A panel throughout the presentation. And if something super relevant and very timely comes up, then one of the three of us will chime in with that question. Do please use the Q&A panel for questions. That is the best way to go. We do end up getting questions in the chat, which is great too, but the Q&A panel, as presenters, we can only monitor so many panels and stay on point. So if you can put those questions in the Q&A panel, that would be really helpful. And then, of course, this recording is going to be sent to all registrants. It will be available after the fact. So no need to screenshot slides. You'll have all of that available to you afterward. So the agenda for today is I had mentioned earlier that uh, that you might be new to either one of these technologies or you might have experience with both. We're going to be talking about the OpenAI agents integration with Temporal. So what we're really talking about here is bringing resilience to agents. And in this particular case, using agents built using the OpenAI Agents SDK. Don't worry if you don't know either one of these technologies. We're going to give you an overview of each. So we'll start with the OpenAI Agents SDK, then we'll do an overview of Temporal, and then we will also talk about that. We'll, of course, spend a lot of time telling you about the Better Together story and even get into the details of how we've done some of that implementation. You'll notice that we're going to do lots of demos throughout. And when Steve is doing the demo at the end, he's also going to address one of the biggest challenges in these agents today is how to do human in the loop effectively, especially while you're maintaining durability. So with that, I'm going to send it over to you, Dom, to give us an overview of the OpenAI Agents SDK because you're working on it.
Awesome. Yeah, thank you so much. First of all, I want to start with like we've probably mentioned the word agents already like 50 times in this call because this webinar is about agents, but everyone sort of has a different interpretation or definition of what an agent is. So when we talk about agents at OpenAI, we talk about an AI application that really consists of a model, be it GPT-5 or a different model that has a set of instructions that sort of define its goal, its behavior, and then we equip it with a set of tools that it can use to um, achieve said goal, and all of that is encapsulated in some level of a runtime to really turn this into like a dynamic life cycle. And so um, we're going to talk a lot in this webinar about the runtime really, rather than sort of like what are the right models. The runtime turns out is a very crucial part of building well-performing and robust agents. So what is the OpenAI Agents SDK and why did we build it? Um, Cornelia, thanks. So the Agents SDK is came really to be based on the best principles that we found when building agents alongside our customers. We have a lot of customers using our APIs to build agents, but obviously we're also building a lot of agents internally. And this came really based on those learnings. And if you've seen Swarm that we released last year, that was really sort of the initial instantiation of this, and the Agents SDK is sort of the evolution from that, where we took what started off as just like a reference architecture into an SDK that hopefully makes it easier for you to build this. And our base principles here are really we don't want to bloat this SDK. We don't want to throw in so many things that is really hard for you to learn. Obviously, it needs to have enough features that it's useful, but we want to make it really easy for you to adopt it. And then we want to strike a good balance between making it very useful out of the box, but then giving you all of the necessary hooks and dials to make it extremely customizable. And I think some of that comes to shine with the work that we've done with Temporal here. So it's available both in Python and TypeScript, but we're going to talk entirely about the Python SDK in the rest of the webinar because Temporal is right now only available with the Python one, at least as like a more streamlined integration. Cornelia, can you go to the next slide? In terms of what this entails for the SDK and what is available. First of all, we built the Agents SDK entirely model agnostic. So like you can use pretty much every LLM, including non-OpenAI ones. In the Python one, we have an integration with Light LLM if you're already using that, or any OpenAI compatible API also works. And then we have a couple of like base building blocks that are built in. One is called handoffs. We're going to talk about that in a second. Guardrails, which allow you to put on rules either as to check input or output and verify that your agent actually stays on track and is not being manipulated. We do support streaming. So if you're trying to build a chat agent that outputs things in streaming, you can do that, although that is not yet supported with Temporal. Tool support, we have both function tool support, but also MCP support. One of the things that is great about the SDK also is it has built-in tracing support. By default, we're sending the things to the OpenAI tracing API, but you can also modify it and use one of the other tracing providers that has support for it. There's a relatively large list, especially for the Python one. And then we recently added a session management support that really allows you to keep track of the conversation and store it, for example, in a database. And it's entirely abstracted in a way where you can bring whatever database you want or whatever session management logic you want to bring, and it just sort of conveniently plugs in. And then the last thing is we also have built-in voice agent support. So if you're building voice agents either with like a text-to-speech, speech-to-text setup or using our speech-to-speech model, both of those are available as well.
Yeah, and I'll chime in here. I love this slide because it shows such a comprehensive list of the things that are enabled with the agent. And you're going to see a lot of these in action when Steve does his demo later today. But you'll see handoffs, you'll see tools, tool support, and you will see traces, which is one of the things that I loved the most when I first started playing with this integration. So really cool stuff.
Cool. So this is like a basic example of this sort of bare minimum agent setup that we talked about, right? So you can import an agent, and as I mentioned earlier, the way we define an agent is we have a set of instructions that we want to give it, which you can see is literally just like a set of instructions, like a string of instructions that we're giving. And then you can define tools and handoffs as a way for the agent to achieve the goal if it can't immediately answer based on the knowledge in the model. And then we take that agent and we run it with some input. And so in this case, it will, like the agent SDK will automatically handle all of the necessary tool calls. So if in this one it needs web search, it will handle the web search. If it needs to, if it would be a question about weather, it would automatically handle the handoff. And it will do that until it reaches a conclusion and then return. And so you don't no longer have to manage that entire loop and sort of continue to shove things in yourself. The Agents SDK will automatically handle that. And then one of the things that we've seen that works really well is to break your setup into a series of sort of micro agents that have more specific parts of your journey defined. So this helps keep the model on track. It also overall helps with like maintainability because you're not ending up with like a massive prompt that you're shoving in every time that handles every possible edge case. Instead, you're defining sort of very isolated units. And as Cornelia already elaborated, this is very similar to sort of like your microservices architecture. And so we have two ways that having, as you're breaking the things down into multiple agents, there's two ways that you can really glue these together. One is handoffs, and then the other is more through like a well-defined code path. So for handoffs, the way this works, you saw it briefly in in one of the previous slides, is you can define other agents that that you created. So in this case, we have three agents that would be defined. One is that we just called agent, and then we created one outside of the slide called weather agent and local biz agent. And we can pass these in as handoffs, and then the agents SDK will inject tools into the currently running agent that allows it to hand off to these other agents. And so in this case, if we have a like local business question, like how late is Costco open, it could hand that query off to the local biz agent and then have that one handle that automatically. And so what happens under the hood in that case, if the model decides it needs to transfer to that other agent, is we're updating the instructions, we're maintaining the session context so the new agent automatically knows what is being talked about. You can, just like with most things in the Agents SDK, influence that and modify it. So if you, for example, want to drop certain parts of the conversation, you can pre-handoff drop those. But then afterwards, we're basically replacing the agent in the current conversation. So from that point on, the new local biz agent is going to work, use its tools and its available handoffs, which could be different, until it ultimately reaches a goal and then returns back in the code, and you can present that output to the user. The other part is really helpful when you actually know what the path should be. So in the previous one, we're completely relying on the agent to decide what is the next agent to call, which is incredibly helpful for complex things like coding agents, where you might have a wide range of different sub agents that you want to, or micro agents that you want to call. For the other path, though, you can use just code, like it's straight up just your Python code that you're used to. And this is when we know sort of the flow of things that we want to do. So we're going to see some of this from Steve, but at a high level, you could imagine, for example, maybe you want to run a more lightweight agent first to collect a bunch of clarifications before you have another agent that you know is going to run for a long time. Or if you want to use an agent that purely does classification and you want to figure out which one do I want to permanently route to, but without having to use sort of handoffs and hoping that the agent is going to actually call a particular model.
Yeah, and one of the things that I'll point out on this slide is you'll notice the HITL I alluded to that when we were talking about the agenda, and that's what you're going to see in action here. So this is one of those instances where, as a part of the code path, part of the application implementation, we've decided that there's this branch which requires clarification from the user. And so Steve will show you how we implement this human in the loop later on when we do that demo. Cool. Ah,
Oh yeah, there you go. So this also allows you to like do things like fanning out, for example, and running multiple things in parallel, right? So you could have an agent, for example, write out a plan and then delegate individual tasks to multiple agents in parallel to work on a project. And so like defining those things in code is much easier as it sort of maps to the code you're probably already writing, especially if you're writing agents. Steve, you want to show us some demos?
Oh, Cornelia, you're muted. I think you're gonna run the Hello World first.
yes, you are right.
Awesome.
I am going to run some super basic Hello World demos because it's going to allow you to see what some of these individual components are. And then Steve's going to collect a bunch of those individual components into a more complex use case. So let's see here if I can get to my demo. So I'm going to come over here and uh, run this first agent. So this is the simplest agent. I think every single agent framework out there has a hello world that does haikus. And so what you can see here is that you can see it's quite familiar. It's simpler. It doesn't have any tools defined. It doesn't have any handoffs defined, but an agent can be that simple. It can really just have a set of instructions. And of course, those instructions go into the context window that is invoking the LLM. And then, of course, you'll notice the runner.run. So that is the thing that represents the agentic loop. In this particular case, we're not going to loop unless the LLM kind of botches the job the first time, but it's usually pretty good at creating the haikus with a single time through the loop. I'm going to go ahead and run the agent. And so that's what is happening there. And now I'm going to ask the agent to do something. So the agent's ready. It's waiting for an input. And so I'm going to go ahead and run that. And that's all that happened. So you can see that it came back. And you'll notice that in the window here, you can see that it made downstream requests. Of course, it made requests out to the LLM. And really, the point there is even in this simple example, we've got a distributed system. So I'm running my agent in one process, but it needs to make a downstream request to the LLM. You can imagine that as soon as we add tools to the mix, as soon as we add handoffs, those types of things, those themselves are going to be calls to additional services down the line. And so that's really what we're talking about here as a distributed systems problem. So with that, let me just go back to slides for just a bit because I had promised to introduce temporal to you. So we've used that term a few times, but for those of you who are not familiar, let me tell you a little bit about temporal. Temporal is a technology. It's an open source project. The vast majority of it is MIT licensed. There's a small part of it that is Apache 2 because it's been around for a little bit longer and it was created before. Temporal was something that came out of a project, another open source project called Cadence. If you've heard of that, that came out of Uber, and our founders actually built Cadence at Uber, and then later on forked Cadence and created Uber, and then have evolved it significantly as an independent technology. What it does is it supports a programming model that allows developers to program the happy path. Those of you who have been doing microservice architectures know that there's an awful lot involved in bringing resilience to those microservice architectures. Let's say you're just doing a request response, you have to implement all sorts of patterns like retries yourself. And then as soon as you do retries, you have to put circuit breakers in place because you don't want to overwhelm the downstream services. If you're moving over to event driven, that's where you have to bring in Kafka. If you want to do state management, yep, you got to bring in your Redis. So there's a lot of work that you've had to do as a developer. And in fact, I wrote a book about these patterns myself that taught people how to do all of these different patterns. What temporal does is it takes the burden of all of that distributed systems plumbing off of the shoulders of the developer. You get to program the happy path as a developer, and we take care of all that plumbing. The platform comes in the form of a service, and that service, I'll show you a picture in just a moment, that has all sorts of durability. All of that plumbing is kind of in the service, but it's not only in the service, the plumbing is also implemented in SDK. The SDK is available in a bunch of different languages. Um, Dom already pointed out that the integration that we're talking about here with the OpenAI Agents SDK is only available in Python today. We are planning support for the TypeScript version as well in the future, but currently we're just talking about Python. So let me tell you a little bit about that programming pattern, that programming model. There's really two fundamental abstractions that you as a developer are going to use. You're going to think about activities, and activities are, if you will, all of these distributed systems actions. You can think of them as kind of downstream APIs. There's a number of other uses as well, but for now, let's just think about them in terms of APIs that are probably making calls over gRPC or HTTP, or might need to be invoked over some event-driven protocol. And so here's a simple example. I've got an API that does a withdrawal from a bank account. I've got an API that does a deposit. And then I've got another API that's going to do a refund if necessary. So think of those as kind of the foundational building blocks. And then the second primary abstraction is something called a workflow. And a workflow is basically the way that you wire these different activities together. So it's the way that you can wire up, okay, I'm doing a money transfer, so I'm going to do a withdrawal followed by a deposit. And if for some reason the deposit failed because that account doesn't exist, then I can issue a refund back to the original account. Where the magic happens is when you put workflows and activities together, then it takes that diagram that you just saw a moment ago and it layers in all of this distributed systems plumbing. So it adds automatic retries. It injects event queues in between these various steps, because we all know that we can't do request response all the time because we need to have durability around the messages that are flowing between these different steps. And we inject state management as well so that we know where we are running through this process. That's really kind of the foundation of Temporal. So now let me go back to the Hello World demo. So it's the very, very same thing. And it's the same example. So the workflow here, so the activity is the LLM call, is the orchestration of, hey, I'm taking in user input, which is tell me about recursion, and I'm sending that off to the LLM. I'm getting the response from the LLM. I'm formatting it and giving it back to the user. Now, I'm already running my agent, but now I'm going to throw a little bit of a wrench in the loop. I'm going to enable a firewall. Let's just go ahead and enable this. I have to type in want to get it right, my password. And so now what I've done is I've enabled a firewall rule that has essentially broken the network. My Wi-Fi is still up, obviously, but I've broken the network from where the workflow is running, where the agent is running. And I have, and the connection out to OpenAI for the LLM invocation. So now what happens when I run this is I'm asking for the same thing, tell me about recursion, and you'll notice that I'm not going to get back any response. And in fact, you're starting to see up in the middle window here, you're seeing some errors getting thrown. And those are really just temporal, because this is running in temporal letting you know that there's some kind of a challenge. Now it's not, notice that it's not crashing. It's not saying, oh, I've given up hope. It just is temporal letting you know that it's experiencing some problem. It's all that plumbing that it's doing on your behalf. So if I come back over here to this window, and I go to my temporal UI, you can see here that that earlier workflow that I ran the first time I ran the agent, it's right here. But what's happening now is in this particular workflow, I am not able to access the LLM. So what you can see here is it's trying to invoke the model, and it says activity, it's an activity, and it's on attempt 7. Let me come back over here and enable my disable my firewall. So I'm going to disable those firewall rules. And in just a moment, there's an exponential back off. So it depends on when that happened. But in a moment, what you're going to see, there you go, is that you see that it came back. And now all of a sudden I can access the LLM and it executed the workflow. So if we scroll down here, you can see the whole history of this orchestration that happened, including the fact that it took me 9 attempts to get back a response from the LLM. So that's pretty cool. And I'm also going to show you another failure scenario because I mentioned that it does things like retries, it has queues that it injects, and I mentioned that state management. What I'm going to do now is I'm actually going to enable my firewall again. I'm going to run, I don't know why my response didn't come back here, so we'll see. Demo gods. And so now I'm going to run that again, and I'm going to actually stop my agent. So I'm going to, oh yeah, eventually it timed out. So I'm going to stop my agent and Control C out of this. So now the agent's not running. So it's not even. And if I come back over here to the workflow, where is there we go. If I come back over here to the workflow, you can see that it's on attempt 3. It was on attempt 3, but now the agent isn't running at all. I've actually killed the agent. But if I come back here now and I enable or disable the firewall again, and I bring the agent back, it's going to show you the same behavior that we saw before, unless some weird things have timed out. There we go. It now has closed up. So the agent itself went offline. It wasn't just that the LLM was hard to reach. It was the agent itself went offline, and we have durability around that. So that's pretty sweet stuff. So let me come back over here and see if there was anything else that we wanted to say before I hand it over to a more complex. So, yes, I just wanted to show you a couple more slides. So this is, remember I showed you this slide earlier and I said that all the stuff in light blue is the plumbing that Temporal brings in. Well, here's a slightly more accurate representation of it. That workflow, that withdraw, deposit, and refund, that's in the light blue box on the left-hand side. And it's taking advantage through the SDK of these services that are running in the centralized service. Again, all of this is available in open source. Of course, Temporal is a business. And so we actually run the Temporal service in the cloud. That's our cloud solution. So that's our business model. But you can run the Temporal service also self-hosted, totally in your environment. So all of those services, and that's what gave you that durability, that the retries themselves survived the agent going down because the retries are actually implemented in a stateful service. That's the Temporal service. So now let's put the pieces together. I'll tell you a little bit more about that, and then we'll hand it over to Steve, who's going to give you a more comprehensive demo. I wanted to give you some of the foundational building blocks so that you can see those building blocks in action in this more sophisticated demo. So what we've done with the OpenAI Agents SDK with Temporal is we've taken the durable execution foundation of Temporal, so all of that stuff that I just showed you in the previous section, and we've taken the implementation of the OpenAI Agents SDK, that's the yellow box, which is taking advantage of OpenAI models. And to Dom's point earlier, any models. It's not just OpenAI models. It's any models because the OpenAI Agents SDK supports those models. And those other things that the agent framework brings in, the tools, the guardrails, the tracing, the agent abstraction, the event loop, so the agent loop, all of that comes from the OpenAI Agents SDK side. And what we've done is we've added Temporal into the mix. So how does that work? Well, we've already talked about the fact that Temporal has these activities. And as soon as you have activities, that's where it starts to wrap some of these distributed system plumbing services around that. So the types of activities that we've done in the past are API calls, database access, file system access, really just about anything that's unpredictable. Well, when we move into this LLM world, what are those downstream, those activities? Those things are like LLM invocations, tool executions, agent executions themselves. So when you, for example, are doing a handoff from one agent to another, that is itself a transition, and it's itself something that could leverage some of these durability capabilities. Dom talked about this earlier. I wanted to make, and he already showed you the picture on the left-hand side. So again, we can have the agents themselves. So these are all of these little micro agents. The agents themselves can be modeled as activities. And I wanted to make the point on the right-hand side that you could be doing this even in the scenario where the LLM is driving the flow. You could always have these things happening in a loop. So the just code way of orchestrating agents, that can have its own loop within it, and we can orchestrate these things along the line. So there's all sorts of interesting ways that you can bring
Yeah,
these things.
Cornelia, I just wanted to emphasize that point on the last slide. So planning is a big thing in AI agents right now. Having the agent and the LLM come up with the steps to do dynamically, and then running those steps, and then even evaluating what you've produced with those steps, and then maybe rerunning them or coming up with a new plan, right? These kind of long-running, free-flowing, self-driving agents. Temporal is excellent at that. What you do is you come up with the plan inside an activity. You call the LLM, you return a list of things to do, and then you have the code iterate those through those tasks. And so, yeah, Temporal's especially good, I would say, for long-running interactive agents.
Yep. And you're going to show us that in 1 second. The
Indeed.
last thing I want to show, and then I'm going to hand it over to you, Steve, is I want to go back to the code example. So this is the agent that I've been running. That's exactly the agent that I've been running, but I was hiding something from you in this. I'm going to scroll up and notice what we've done here is we've taken this agent implementation, so this agent declaration, so the code that defines the agent and the code that starts the agentic loop, and it's living within a temporal workflow. Now, I had told you that LLM calls, and there's an LLM call that's happening inside of this agent, that those happen within activities, but you'll notice here that there is not a mention of activities. That's the punchline. That's what we've done with the Agents SDK and temporal integration, is that we are recognizing when those downstream requests are happening, and we are wrapping those things as activities under the covers for you. You don't have to do that yourself in this particular case. And we wrap all the things that need to be done, we wrap those as activities. And that's what you're going to see in action in a much more detailed, comprehensive demo that Steve's going to show now. So I think that's what I wanted to cover. I'm going to stop my share and I'm going to hand it over to you, Steve. You
Awesome.
should.
Thank you, Cornelia. Thank you, Dom. And it's awesome to be here to show you temporal in action for maybe a more complex running agent. I wanted to show you something that was tied to the real world. And a real world example that people know is deep research. Okay, so OpenAI has a deep research feature in ChatGPT where you put in a topic and it will go and fan out and do some web searches, and then it will write you a really nice report. And this can take a while as well. And it's obviously rather parallel. And so these play to temporal strengths. I wanted to show you that the repo here is available. We'll send it out, but under Temporal Community is the organization, and OpenAI Agents demos. The deep research demo is part of that, and there is a neat little 15-minute video of me running this as well, so you can kind of take that away. All right, so what is this demo going to do? Right. So it's deep research. There is a deep research sample in the OpenAI Agents SDK samples, but it's a little less like the real deep research, the real one in ChatGPT, and that's because the sample is not interactive. The real deep research example that you get on ChatGPT will ask you clarifying questions. They actually, OpenAI actually put out a blog post in its cookbook saying, here's how we would do this with the Agents SDK. Here are all the here's the logic. Here are all of the agents we have, and here's how they're orchestrated. So I figured let's implement that. And it looks like this. So this is half of the piece, and in the next slide, you're going to see the end of the flowchart. But the first part is the query preparation. The user inputs a topic. Tell me about this topic. There's a triage agent, and the triage agent, which uses 4.0 mini, because it's a pretty easy job. Do we need clarification for what the user input? If it's a yes, if it's a no, pretty much goes straight through to the research agents. It'll write up a query, like a nice prompt for deep research, and then it'll go to the thing I'll show in the next slide. If it needs clarification, it comes up with a series of questions. It'll come up with 3 questions to better understand the user's topic. It will take those answers to those questions, and then it will feed that to this instruction agent, which comes up with this overall prompt for an enriched query. So it's what the user originally asked for, plus their answers to the specific questions, and then the research begins. And so when the research begins, it's another series of agents being orchestrated. You have a planner agent, and that takes all of that input and says, if I was to fan this out into a series of questions, sub-questions, and web searches, what would those questions be? And so search agents run in parallel, and you'll see that in Temporal in a second. And then once that runs and we gather all that data, the writer agent starts chopping away at turning this into a report. So how would we structure all the information that came back from the search agents into a neat little report? And then the PDF generator agent will turn that into a neat PDF, because the real deep research comes up with a nice PDF, so I wanted to as well. All right, so let's get into showing how this works. All right. So the very first thing I'm going to need before I run this is I'm going to need a temporal server. And the good news about a temporal server is I can just brew install temporal. I already have it, so it should just run straight away. Great. And then you go temporal server start dev. So this is the easiest, fastest way to get a temporal server. No complex setup required. And then you get this URL, which I'm going to paste here, and then I'll show you, oops, 8233. And then I'll show you the workflow view. Okay, so we've got 0 workflows running, but we have a fully fledged temporal server ready to run these workflows. All right. The next thing I'm going to do is start running this deep research example. And fair warning, this demo will probably take between 8 to 10 minutes, and I'm going to make it, I'm going to introduce chaos because temporal is really valuable when things go wrong at scale. And so I'm going to introduce a series of problems throughout running this, and hopefully, with any luck, with the demo gods, deep research will complete in the face of all of those problems. All right, so my query for the interactive research workflow, which you see here, is going to be, where can I find bears in the wild? I'm fascinated with this topic. There are no bears where I'm from in Australia, so they're very exotic to me, just like kangaroos might be to you. So let's start this and then look at that from a workflow perspective. Uh, I also need to run workers. So just as Cornelia was talking about running the agent before, temporal workers execute the workflows. The temporal server doesn't see any of your code. It doesn't run any of your code. You need workers to do that, and I'm going to run 3. So I'm going to run a worker. I'm going to run another worker because we're doing some parallel stuff. So I want lots of worker capability. And all right, we have a running interactive research workflow. This is a bit of dead time before I started the workers, but then you can see things started right off. So we've got a triage agent that ran. Its job was to find out whether we need clarifying questions. Let's see if it does. Yes. What specific what specific type of bears are you interested in? Black bears or grizzly bears? Let's go grizzlies. Cool. Do you have a particular region or country in mind for bear sightings? I guess North America, where I am right now. Before I do that, I might show you again just what the triage agent looks like. So this is the thing that figured out whether you need clarifying questions or not. And it's just a prompt. This was straight from the OpenAI cookbook. It's just their prompt for a triage agent. You are a triage agent that determines if a research query needs clarifying. And then you run it here, and there's 2 handoffs, right? That's the flowchart you saw before. Clarifying agent on one hand, like, do we have more questions to ask, or straight through to the instruction agent to start doing the research. And so that's how that works. And you can see it's a very small amount of code and a relatively simple prompt. All right, so moving on, we're being asked questions here, and you'll notice that when I answered grizzlies before, it came through as an update called provide single clarification. Now, temporal workflows can be interacted with, and that's massively powerful. Temporal workflows can run forever, they can run indefinitely, and you can actually change the course of them with new data or human interaction. And this is what I did here by providing grizzlies as an answer. Now, it didn't do anything because it's got more questions for me, or it just kind of logged that answer. But I just wanted to show you that this is me interacting with the workflow. You might say, okay, workflows can run a long time. That's problematic from the perspective of networks going down, infrastructure going down, your code crashing, etc., etc. Yes, indeed. So let me stop these workers completely. So there are no workers available to execute the code anymore. Let's see what happens to the workflow. Okay, the workflow is still running. The reason for this is temporal service, the temporal server itself, is holding the state of that workflow. This workflow, these workers don't need to run for this workflow to continue. Research hasn't stopped, or the research flow hasn't stopped. We're still in good shape. So if I was to answer the particular region or country in mind for bear sightings, North America, sounds good. Then I've input that, and it hasn't shown up here yet. And the reason is I need to run workers to handle that update. So as soon as I do, you should see this clarification show up. There it is. Right. So just to tell you some more detail about what happened, the worker appeared, these workers appeared, they polled the server, is there any work for me to do? And even though I crashed the code, like I stopped it, that was running the workflow, it goes and gets the state from this server and says, where were we up to? And it sort of rehydrates that or replays that code in the workflow, and then we're back on track. So let's continue. Are you looking for guided tours, or are you planning to explore independently? Okay, that's the final question, I guess. I'm going to be dangerous and explore independently. I'm brave. Great. So you're going to put me out in the wild with some bears. I may not survive. Um, all right. So before I do that, I'm going to introduce some more chaos, just like Cornelia did. I'm going to firewall out the OpenAI APIs to introduce like a simulate some kind of network issue, right? To do that, I need to ensure that sudo is set up because it's kind of time dependent. So let me do that real quick. All right, good. Um, okay, so as soon as I kick off this third answer, it's going to want to do the planner step, which is come up with the research questions. And I'm going to let it do that. But then I'm going to firewall it out immediately on the fan out. And so as soon as those web searches start, they're going to find out that they cannot contact OpenAI's APIs because I've firewalled them out. And I just want to show you what that looks like. All right, here we go. Explore independently. I'm brave. Boom. Firewall. Block research traffic rules. Okay, so because the planner agent got its query out like to OpenAI before I firewalled it, it came back fine. But you're going to see what happens to this fan out. Like each of these are individual research questions that may have web searches behind them, all running the OpenAI Agents SDK. And you can see that most of them at this point are orange. If I go into why they're orange, we're already retrying. And so temporal by default will retry based on a retry policy. It's trying as hard as it can to contact OpenAI. It's not going to work because I firewalled it out pretty solidly, and it says request timed out. So if I scroll down to the bottom here, you will see connect timeout, API timeout error, so on and so forth. Let me rescue this, and so research can continue to do that. I'm going to go to my backup rules, which should unblock OpenAI APIs, and then we should be back on track. There we go. All right. And one other thing you'll notice, there's a couple of stragglers, but they should complete. Yeah, here they come. The thing you should notice here is obviously there's a little bit of orange or red in those green. That means that there were some failures, right? We had this was attempt number 6 that it succeeded. This one was attempt number 5, but you'll see that this fan out succeeded. It was parallel. In reality, you'd run a ton of workers to handle this. Like people run entire fleets of workers in Kubernetes pods. They run them in multiple regions in like highly redundant setups. This is the power of temporal. You can do all this stuff to your long running flow and it won't miss a beat. So the step we're doing right now is the writer agent. And that's gathering all the information it came back with from the fan out. And while that's happening, I think I might show you what the writer agent looks like. So again, it's another OpenAI Agent SDK agent. It's very bare bones. We're using O3 Mini to do the writing. And the output type is defined here, short summary, markdown report, follow-up questions. That's in line with the cookbook example. And then the prompt is, you're a senior researcher tasked with writing a comprehensive in-depth report for a research query. Again, straight from the OpenAI cookbook. It looks like it's done. And you can obviously click into the activity as well to see what was done. You can also go into the traces because tracing is still supported in the integration. So if I click on the clarifications, for example, it'll show that it did a handoff from the triage agent to the clarifying questions agent, which is what I showed you before in the code. And now the PDF generator agent runs. And this is the part where I get the most nervous because we are right now, I think, in peak ChatGPT time. The West Coast of the US has woken up. Europe hasn't finished work yet. And so the APIs may slow down a little bit, and it may go beyond the timeout policy of this activity. So let's all hold our breath. It usually takes about a minute and a half or 2 minutes to complete, so I'm not worried yet. Oh, okay, there we go. Perfect. I managed to vamp my way to success. All right, cool. So we're almost done. We've got generate PDF, invoke model activity, PDF generator agent. And if I go in here and I open this research report, yes, oops, that's not this one. It's this one. Yes. And we get this full report based off all what happened here. If I scroll up, exploring grizzly bears in North America, an in-depth guide, exploring grizzly bears in North America. Okay, cool. And it's going to give me a bunch of stuff based on my follow-up questions and independent searches that it ran. And you can see it's really well structured. Like this was the PDF writer agent in full force. I'm using a tool, a particular PDF writer tool that I feed to the agent, which I'll show you. This is possibly the last thing I'll show you unless there's sort of follow-up questions from anyone who wants to see anything else. But we have PDF generator agent. And if we go in here, you can see that the PDF generator agent uses a tool. Now, we wrap this in a temporal activity. That's what gives it its retriability. That's what makes it run, at scale, in parallel, on our workers, all that good stuff. But fundamentally, we are feeding a simple function called generate PDF. And that's how the PDF generator agent knows what to do. Now, I actually plan to simulate a bug here, but unfortunately, I fixed the bug before running this demo. So let's imagine that there was a bug. So like, this instead, which is not a function. What would happen is the activity would have stalled and kept retrying, and I would have had a chance to actually fix this code, restart the worker, and then again, research wouldn't have been lost. Research would have been back on track. So for real operation scenarios, or even just coming up while you're prototyping your agent, this is fabulous to save on LLM calls, to save on time, because if something goes wrong, and you're 10 steps in with your agent, you can rescue it. So that's all I wanted to show in this demo. Hopefully that resonates. It's a very real world, long running, interactive, parallel use case. And so I would highly recommend you check out the sample, maybe check out the video and deploy it, and then let me know what you think and let me know what you build.
So Steve, not to put you on the spot, but do you have the traces are shown in the OpenAI console by any chance? Or did
Yes,
you?
I do. So which ones do you want to see specifically?
But no, I just wanted to, and I'm sorry, I was answering questions. So did you already show this? Did I just miss it?
Um, I did, but I didn't show
Okay.
the search one, which is kind of because the search was still being run. So this is really interesting to see. That's the search agent. That's not what I wanted to see. There is the fan out workflow, which I'm trying to find. Agent workflow. Uh, okay, there is a view where it's like, here is my fan out of questions, but I wasn't planning on showing it. There you
Yeah.
go. Okay.
And that's good. If you just leave that up for a second, what I did want to point out there from the way that this is done is that you, as the developer, have the opportunity to essentially assign trace IDs to various invocations. And so you are yourself, you know what constitutes your overall user experience that has all of these micro agents that are being invoked, and you can connect those things all together. So Steve was showing you in the temporal UI how we keep all of those things stitched together in the temporal UI. The way that you stitch all those things together in the context of what is showing here in the traces is with trace IDs. And
Yeah.
so I
And
find
I
that
would say
incredibly powerful.
that it's very powerful, and I would say like this is obviously your agent view, your LLM view, and the fact it's integrated with temporal doesn't hamper it in any way. You still get the full view, and then for your distributed systems view, you kind of get the temporal view because of course you might not just be calling OpenAI agents here. You might be calling all kinds of systems, all kinds of downstream services. Temporal is polyglot, so your workflow might be written in Java and might be calling Python activities that run agents, or might be the other way around. You might be using the Agents SDK in Python, that you must call in .NET. This is your generic distributed systems view with full detail, and then you get the agent view still preserved.
Awesome. All right. We are running a little short on time. I know I said 45 minutes, but we've gone a little over. That's okay. All of it's being recorded. So if you want to go back to the slides real quick and bring up the slide with the QR codes, so you can get your hands on more information across all of these things. So there's a blog, for example. And you can see this demo video that Steve has just given you. Steve and Dom have a video that they did that shows all this. And then there's the GitHub repository that has this sample that Steve has been executing. So you can get your hands on all of that. So with that, let's move over and take just a handful of questions live. We've been answering quite a few. We've had a whole lot of questions. So we've had over 30 questions. And we've answered quite a few, but let's go over to the questions. And I'm going to start with one that was specifically addressed to you, Dom. It says, hello, Dom, can you please explain about the context management when using temporal activities? Specifically, what is read only?
Yeah, there were a couple of ones that I'm gonna group together that came up around this because I need to start with like a clarification on like two, developers are poor at naming things, two things that are related to context. So, um, generally, when you build with LLMs and you think about context, you're normally talking about what is the text, the tokens that you're putting into a model call as it's being executed. Um, the other part of type of context that we have in the Agents SDK is essentially a context object. Let me briefly share my screen here. Um, see. Um, okay, I think you can see my browser now. Um, so the other part is a context object. So this is what when you're reading the Agents SDK documentation that you might see as context. So in this case, one common example would be like, let's say you're writing all of your prompts and you want as part of those prompts, whether it's like the prompt for a tool description or the prompt for like your instructions, you want to reference some level of information that is like that isn't available to you as you're writing the prompt. That's the type of context object that we have additionally. So like common example would be like the user information, right? Like a name and maybe a user ID. And then what that allows you to do is you have access to that user information in various places. Like you could change you could have an instructions set here, like an instruction that is actually a function that takes in that context and then returns a like formatted string, or you can access it, for example, during the tool call. Um, that is the other type of context. So this is the context that we're talking about that is like read only, that is being passed in at the beginning. And it is, as you can see here, it is not that object is not being sent by default to the model. It's a way for you to keep track of data locally, and then you can write methods and to use that to uh, match things. Does that make sense? Um, I guess I can't see the chat, but like Um, that is the first part of that question. I think there was a question around how do you deal with like context for handoffs happening and like context growing over time. Um, One of the things that you can do with handoffs specifically is by default when a handoff happens, the entire input that has been collected so far, or like the traditional context, is being passed to that new agent call, which isn't something that you always want to do. And so that's where you can use these input filters on handoffs. So let's say you have, if we go up here, let's say you have three agents, right? And you have a triage agent, you have a billing agent, and a refund agent. And that triage agent might have additionally two handoffs to these other two agents. It has some tools to answer common questions or other things like that. That might not be, and so like as a user asks a question, the triage agent calls the frequently asked questions tool a bunch of times to answer questions, eventually realizes they need to escalate to a refund agent. You probably don't want to pass all of that context of like previous tool calls to the next agent as the handoff is happening. And so that's where you can use these input filters. So an input filter is just a function that basically gets the list of like all of the input items, like whether it's tool calls, reasoning traces, messages, etc. And then you can decide what you want to filter out. We have a default one called remove all tools. You could just use that, but maybe you want to do some additional modifications there. And for example, take the entire text, summarize it first, and then hand it off, or other things. Like you can do all of those things through these additional hooks.
Okay, very cool. I'm not going to fully take another question, but I do want to acknowledge that many of you have asked more information around human in the loop practices. So for example, there was a question around, well, can you set a timeout on the human in the loop if it's going to take a long time? The TLDR on that is absolutely. And one of the things that I didn't call out is one of the services that Temporal offers is a durable timer, so that you can implement, for example, a timer that says, hey, we're going to wait for human in the loop, but at some point we're going to time out on that, and we're going to either error out or we're going to proceed with the best guess that we have. You have the ability to implement all of that. It turns out I had called it out during the agenda that human in the loop is a really, really challenging problem in this kind of agentic world that we're at. We are doing a lot more work on formalizing those. We are, for example, for those of you who are in the San Francisco area, we are doing a in-person meetup specifically around this topic of human in the loop on October 16th. So you can reach out to us if you can't find that. We can let you know where that is. But a colleague of ours is on who helps us with all these webinars. Hannah, I'm thinking we should do a human in the loop session sometime moving forward. With that, we have hit the top of the hour. I know there's still a lot of open questions. I invite all of you to join us in our community Slack and our community forums. We will follow up on all of these questions and point you to the answers to those. So keep an eye on that over the course of the next several days. And with that, I want to thank both you, Dom and Steve, for partnering with me on what I think was, for me, a super fun webinar to do, and I hope really informative for our audience. Any closing remarks from either of you?
Thank
Thanks
you,
for having me.
Cornelia. Yeah. Thank you, Dom. Thank you, Cornelia. And
All
great
right.
to
Thanks,
see you.
everyone.
Thanks, everyone. We'll talk to you soon.